Looking at question 5, parts A and B, I think B is a little bit easier than part A. And the reason I say that is because here in B, if we look at the x's, they're going up by 1, going up by 1, going up by 1. It makes it a lot easier when this is going up by the same amount, because then we can see if this goes by the same amount, it's going to be linear. So it's saying determine whether it's linear or not. If it is linear, we're going to write a function, but if it's not, then we just have to say why it's not linear. So when we look from here to here, this went up, right? It was -9, think on the number line, -9, up to -4, it went up 5. And then when we go from -4 up to 1, it goes up by 5. But then from here to here, it only goes up by 4. So it's not going to be linear. So not linear. And if this goes up by 1, this would tell me what my slope is. So our slope is changing, which makes it not linear, okay? Not a constant slope, or not a constant rate of change there. All right, then if we look at the one over here, the reason this one's a little bit tougher is, okay, it goes up by 1 here, but then it goes up by 3 here, and then it goes up by 1 again here. So what we want to do is we want to check the slope between each of these. So if we check the slope between these, if you remember from page 1, we can do our slope by doing our change in y's over our change in x's. So if I do that from here to here, my y's, -8 minus -11. And then my x's are -3 minus -4. And it's easy to mess up when you got those extra negatives in there, but this just turns into a plus. So I get 3 on top, and I get 1 on bottom. I'm going to switch colors just so I don't get them all mixed together here. So when I look from here to here, I'm doing the change in y's first. I'm going to do 1 minus -8. That goes on top. And then on bottom, 0 minus -3. 0 minus -3. So this just turns into 1 plus 8, so 9, over 0 plus 3, so 3. That's the same thing. Okay, this is 3 over 1, which is 3. This one's 3, so I feel pretty good about it, but could do something like this again. So then we'll go ahead and we'll check the bottom 2 points here. So change in y, remember the y's go on top, so we do 4 minus 1 over 1 minus 0. So I get 3 over 1 again. So this one is linear. So determine whether it's linear. So I'm going to go ahead and write linear to start with. And then it says, for those that are, write the function. So we can do our function would be like f of x equals, or we've been using n. It's fine if you say f of n equals. But we're writing this equation, y equals mx plus b. I'm just writing it in function form. And the m here is my slope. And the slope is what I just found here. Okay, it's 3 all over the place. So this is going to be 3x. And then plus b, this is my y-intercept. And your y-intercept is when the x is 0. So my x is 0, so this is my y-intercept would be plus 1. And that's what it's asking you to do, is write that function. All right, so down here, calculate the average rate of change for our f of x. So average rate of change is really just saying find the slope. So slope, we can do rise over run. A lot of times we do that when we see the graph. But if you really wanted to, you could pick 2 of the points off of the graph, and you could use this equation that we used up here, and you get the same thing, okay? A lot of times when we see the graph, we just do rise over run. So I'm going to find a couple corners on the graph. We want to find spots where we're sure it goes through those corners. So I'm going to go here and here. And my rise is 1. And make sure the units are going up by 1, so they are. So my rise is 1. And then my run, let's check this, they're going by 1s. So my run is 1, 2, 3, 4. So rise is 1, run is 4, so 1/4 would be my answer here. Then this says, using the graph below, how many gallons of gas can be purchased for $31.60. So $31.60 is, this would be 35. So 31.60 would be right about here. And if we follow that over, it looks like it's about 8. So it'd be 8 gallons. So we'll just say about 8 gallons.